Welcome to Async, the local web tech meetup for Brighton and Hove that's been running kind of since forever, at least since Node.js came out. Was it 2010? Does anyone remember the first? Yeah, something like that. Yeah, for like a very, very long time. It's lovely to see you all, some familiar faces, some new faces, which is exactly what I want to see. So tonight we have a wonderful speaker. It's third time on the Async stage, we think, something like that. But before I introduce him, I just want to say a couple of points of order. Number one, most importantly, Dave, thank you very much for getting this up. We got the code of conduct right there. If you scan it, you will see our code of conduct, or go to asyncjs.com/code of conduct. You can scroll to the bottom and there's the link. The TLDR is please be nice to each other. If anyone makes you feel uncomfortable during the session, come and talk to me, because I'm the only organizer tonight. So yeah, just come and talk to me, basically. So I want to say two very quick thanks. The first one, the pizzas that you have noshed down on, which were very good, have been provided alongside this beautiful space by Sam and Runway East. A huge thanks, Sam, and a huge thanks to Runway East. A wonderful space. Like, I can't express enough how grateful I am. And the second point of order, they are not here tonight, but Silicon Brighton have been the lifeline that have kept Async going through the pandemic years and through everything else. They usually have a couple of people here to run the AV, but they are like superheroes sometimes called away to fight other fires, and they are hosting a conference tonight as well. So we are on our own, but they did not forget about us. They have provided us with the beers and various other drinks that you've been drinking tonight. So a huge thanks to Silicon Brighton. So Dave's friend made it, good work. So tonight it gives me great pleasure to introduce Dave Gurnell. 2 weeks ago, less than 2 weeks ago, I think it was, I asked Dave if he might be able to step in with a quick lightning talk because we had another speaker and we wanted to sort of pad out the session a little bit. The other speaker is unfortunately unwell this evening, and so everything falls on Dave's shoulders. And because we don't have Silicon Brighton, we don't have the AV set up. Yet again, Dave has come and he's brought his webcam and he's brought his microphones and everything, and his streaming. Like, we are very blessed, not just in having such an excellent speaker, but in such a chilled roll with the punches kind of guy. And so, yeah, please put a huge and very grateful round of applause. Yeah, whatever, to Dave Gurnell. Thanks very much.
So, all right, well, it's your turn to roll with the punches for the talk, I guess. How do I make this not be full screen? Hello. Please go away. All right. And then I don't have Keynote open anymore. Okay. Oh, still got the slides. Yeah. Thank God for that. Right. Okay. Hi everyone, my name is Dave, as Ali said. I am a full stack developer, I guess, based just up the road at the Skiff. I do a lot of TypeScript, a lot of Scala. I'm very into functional programming. I do consultancy and training. My name of my company is Spacecat. That's my email. Please get in touch if any of this is interesting to you. But self-promotion aside, here tonight to talk about something called local first software. Who here has heard that term before? Okay, a few, not all, brilliant. So a bit of an admission, I only came to this term about 6 weeks ago. So I'm not talking the point of view of a complete expert here. So I was doing some research for a web app that I'm building with a colleague, and we were looking at various different things, and I kind of fell down this rabbit hole, this really fascinating rabbit hole about this new way of building software. And so what I want to do tonight is to sort of tell you what it is, and why I think it's really exciting, and talk through some of the approaches that people use to do it and some of the tooling they use to do it. So the punchline is it's quite hard. So don't necessarily come away from here thinking, I'm going to have a silver bullet, I can do this now, but hopefully it'll be interesting and we can have a chat about it. So the term local first comes from this paper. It's kind of a thought piece out of a research institute based out of Cambridge Uni called Ink and Switch. And really they're talking about, kind of the state of web development at the moment and what we could do to improve it. It's a really good article. It's fairly non-technical. It's quite long and detailed. I recommend it as a read, but essentially it boils down to local first software is software that runs locally, so offline without the network, but can still benefit from having access to the network for sharing, backup, collaboration, and so on. And so to kind of really dig into this, I thought we would go through a little thought exercise. And I thought we would build an application together. So we picked a to-do MVC application because that's the thing you do to demonstrate every programming technique. But I don't want to build a web app. I want us to think back into the past. We are going to build an app for desktop PC. So I won't ask you who was programming computers in the late 80s or early 90s. I was. And hopefully we can enjoy this experience together because it's quite a nice experience. There's no internet yet, or it's nascent and no one's really got mainstream access to it. So we're building an application as a very simple thing. This is my architecture diagram. We're going to build a user interface and some kind of data store. So it could just be a flat file. It could be something more advanced, whatever. And then the application is going to work by, when you boot it up, it will load data from the store, bring it into memory. You can tinker with it and edit it. And then as you're making changes, we'll save them back to the store. Cool? If any of you went to uni to do like first year programming, you probably built something like this. This is the kind of thing we're talking about. Now, the great pro of this is it's incredibly simple. So it's simple from 2 points of view. One is there's only one programming language involved, which, if you're a web developer, that's probably quite an enviable state to be in. One programming language, oh my God. And so the developer experience is quite straightforward. And also, because the code and the data are all on one machine and everything is immediately accessible, you get a lot of performance for free that we don't get when we're programming on the web. So the user experience is better. No spinners, that kind of thing. But of course, the con is that this thing is not networked. So if I want to take my to-do list and put it on my fancy new laptop, I'm going to be doing it the old way, the old-fashioned way. Okay, so clearly this is too inconvenient. No one wants to do this. So let's fast forward a few years and come to the interwebs. So the internet comes along and that's going to change everything. And now we can rebuild our app as a web app. Okay, architecture diagram's slightly different now. We have a client and we have a server. And in the client, there's a web browser. And so, I mean, a lot of you will know this. You know that the browser will request a page from the server. The server loads our to-do list from the database and sends it back as HTML. The user tinkers with it and then posts some form data back. Nice and simple, old school. So in some ways, this is very similar to what we had before. This 2 boxes on the right here with the sort of the user interface, either the web server and the database, I've intentionally made look the same. And it's kind of doing the same things. There's an initial load, and you send the data across the network. And then as the user makes changes, you save them back. But we have this network connection in the middle that causes no end of problems. And you might think, they're like, well, look, this is a bit of a contrived thing, isn't it? Like, we don't really send HTML over the web. I mean, we don't build apps like this. We don't do form posts anymore. We use React and we use Svelte and we use REST APIs and GraphQL. This is the architecture in a modern web framework. The data that we're shipping around has changed slightly. The HTML is already here. We're using a REST API or GraphQL and we're just sending JSON back and forth. But fundamentally, nothing has really changed. So 2 problems with that, possibly 3. I can't remember how many slides I've got. One is every time we load some data from the server or save something back, we're waiting for it. It might be a small wait, but we're waiting for it. And we have to put a spinner up. And there are ways of mitigating this. You can cache things all over the place and use React query and you can use CDNs. But if you refresh the page in your web browser, I bet all that caching is blown away and you start from scratch. So we're still stuck with this. And we have one server now that's serving all of our clients. And so we've introduced scaling problems. And it's a to-do list. And so if we want to serve 1 million different users, we're worried about scaling that server. And one of the things that's caused us to do is that web development is almost entirely like stateless in the long term. So not only are we having to do this fetching all the time, but we're having to do it every single time we want the same bit of data. And again, there are ways of mitigating it, but it's a problem. The third problem is the moment that server disappears, everything breaks. So if you go on the tube or on a plane, you can't do it. So pros, internet, sharing, collaboration, data is safe in the cloud. Cons, we've basically made our developer experience very difficult. It is unreasonably complicated to build this application now, I would argue. And we're having to suffer with poor performance and no offline support for the users. We're basically providing a less than ideal experience for the user compared to the local app, and it's 10 times harder for us to build it. So the idea behind local first software is to take the best of both these worlds and merge it together. And this is my title slide. Rather than saying local first, I put a mobile app up here. And the reason I put a mobile app up here is that mobile developers have kind of been doing this for quite a while now. So when smartphones came about, when was that? We talked about the first 2007, brilliant. When smartphones came about, and then when the app stores opened up, people found all these new apps, and they're like, yeah, I love this native feel. Well, it's a native feel, it's so smooth and immediate, and I've got great animations and all this kind of stuff. And I think as web developers, we often put that down to the programming language. Well, we've got to program JavaScript, right? And we're in a browser, but you guys have got like Kotlin and Swift and Objective-C and all these kind of things. Of course, it's going to be like more native feel. But I'd argue that a big part of the problem is the architecture. A mobile app has got a local database, so it's not. It doesn't have half of the lag problems that we have building on the web. But the good news is that web browsers are cool these days, and we have progressive web apps, and we have really big databases in the form of things like IndexedDB. In fact, there are even, do you know, you can run SQLite and Postgres in WASM these days. And it's not just like a weird research experiment, it like works stably. So we can do what we're doing on mobile on the web as well. We can have a local database and we can get this kind of original architecture back. But to facilitate sharing, we need some way to exchange data between those clients. So you see people talk about a sync server or a sync service or something. So the clients are doing what our local app did originally, but as they are loading and saving data, they are sending it to and from one another via this sync service. Now, the sync service could be something really heavyweight, like a traditional sort of API server, the kind of thing we're already building, or it could just be like a tiny exchange, a bit like the sort of intermediary you use when you're doing is it WebRTC, the video thing on the web. You go, oh, I'm going to connect to this guy, and then all the data kind of just goes straight through the server and out the other side. So we can work offline now. And because we're operating locally, we can get rid of a lot of the spinners, hopefully. And theoretically, the developer experience is better, but I think that's better once you've solved all the really hard technical problems. But there's another thing, which is we can do multiplayer user interfaces. How cool is that? Here are some fun demos. I've got Figma here on the left and Linear. Does anyone know Linear on the right? It's like GitHub issues. It's like an issue management, project management tool. And both of these are built the same way. So they've got local databases in IndexedDB, and they're doing this sync thing. And I've got web browsers and Electron apps, and as I change something in one place, you see it change in the other. And it sort of happens pretty much instantaneously. So not only can people work offline, but they can also collaborate with one another much easier. Like it's no different sitting next to somebody on the same computer or having your app on your computer and their app on their computer, and you see the same changes. So the pros are more or less the pros of local and remote brought together. But the con is very simple. How the hell do I do this? So let's talk about how the hell we do this. So this is where I've done a lot of reading on this, and I'm kind of feeling out the different products that are available, the different libraries that are available, and the different ways people have done things. Good news is there are a lot of resources out there, and I'll give you one link at the end, which is a brilliant start page for checking all this stuff out. But basically, there are three kind of approaches, I think. I'll walk through each of them in turn, so I won't read them off the slide here. The first one is, I guess, what I would call event sourcing, but I'm kind of a back-end programmer. You could call it being like a reactive architecture, maybe. And the DIY part means you're basically building the thing from scratch. And this is what these guys are all doing. They're building their architecture from the ground up. So what this means is it's all done in application code. You've got your apps here. I was meant to write UI up there, and I wrote app instead. You've got your apps running on different devices, and what you're doing is you're building a thing called a sync engine in between your user interface and your storage. And so what would happen there is you would start by downloading data from your API server, your sync server. You immediately shove it in your local database so that the next time your app starts, it's quick, and you'd immediately render a user interface. And then, as the user's making changes in your user interface, you're doing it a bit like you do it with Redux. You've got little objects representing each change, like a JSON object with assign task to user or add word to text field or something. And you're sending them to your sync engine, which is storing them locally in like an optimistic fashion, optimistic updates, but it's also queuing them to go out to the sync server. And I say queuing because if you drop offline, you've got this queue, right? So you've got to go, okay, I'll come back online, I'll flush the queue, and I'll send all these messages out to the sync server. And then the sync server is free. But the sync server in I think all of these applications is a sort of a source of truth. It's got its own database, and it is sort of considered to be the canonical version of all the data. So it's either going, well, that was a great change, I'll apply that locally and send it to everybody. Or it's saying, actually, you're trying to do this action, but I know a bit more than you don't. Like, you've assigned this thing to Dave, but someone else has just deleted Dave's account, so we can't do that. Take your action back and reverse it. So you have to have rollback. So, pros and cons wise, you've got lots of control, but my God, building this from scratch, there's a lot of work there. We're talking about, building your own database interfaces, using WebSockets or long polling to talk to this sync server. We're talking about having rollback of any changes, if they get rejected by the server. There's lots and lots going on. There are a few libraries that help with it a bit, though. So if this is something that seems interesting, I'd recommend checking out this thing called Replicache. It's technically commercial software. The people who built it are now building a new thing, so they say they're going to open source it, but it's got free for open source, and it's free for open source, and it has sort of fairly reasonable commercial pricing. And this gives you an architecture to do this kind of thing. So if nothing else, you can read the docs and see how they kind of frame this. The second kind of way of doing this stuff, if you don't want to roll it yourself, is you could rely on a sort of syncing database. And the idea here is you take this synchronization stuff and you move it down to the database level, and you're just using an off-the-shelf database that does this for you. So has anyone written stuff with Firebase before? Okay, so I haven't. I've looked at some code samples, and Superbase is like an open source alternative based on Postgres. These guys kind of do some of this stuff. I don't think it doesn't look as clean as I want it to, but I might just be ignorant of how the whole thing works. There are also some new solutions. This thing, InstantDB, and this is Electric SQL. Electric SQL is really interesting. That's a company, they built this embeddable WASM version of Postgres, and then it synchronizes with Postgres on the server, like a replication layer. So there are products out there. They're in various states of various ages. Some of them are new. Some of them are like really battle tested, and they will do this for you. And so that makes your life a bit easier. I had a weird rogue slide there, but you're kind of you end up baking a lot of stuff into the database. For example, with Electric SQL, you do your authentication and permission management through the database. You're writing SQL to do it. And that feels like, if you've got a new project and you're willing to just get really involved in your database, then that's fine, but it feels like something that might cause problems to me. And of course, there are hosted versions of all these things, and possibly lock-in. I mean, in a sense, you can export your data from a database, but if your database is managing your authentication and your permission system and all your data and your replication, switching products is going to be quite interesting. Okay, third approach, and this is the one that I'm most excited about as a sort of a developer in a small team. CRDTs. Does anyone know what CRDT stands for? There's at least 3 different things that it stands for, depending on who you ask. The one I'm going for is conflict-free replicated data types. So as you can tell, it's an academic term. But this sort of simple layman's version of it, and I'm not an expert on this stuff anyway, is they're kind of data structures that carry around their own history. So within your bit of data, you have the values that you're using, and you also have enough information that you can take that data, send it to different people, they can perform different operations on it, and then you can merge the changes. So it kind of does the syncing for you. Now, the last time I heard about CRDTs before I was looking into this was a few years ago, and they were these really like very academic things. Like, this is this great data structure, but it's for making sure a counter is synchronized between all your clients. And if it goes up, everybody knows it's going up. If it goes down, everybody knows that it's gone down. And it was that kind of thing. So you had to find the data structures you wanted to use, and it was all very manual. But these days, this stuff has come a long way. And so like there are like really mainstream applications that are based on CRDTs. This Goodnotes thing on the right here, by the way, is like a graphical like note drawing kind of app. Yeah.
So is it like every data structure has its own kind of like Git history or something?
Is it like every data structure has its own Git history? So there are technically speaking, there are different kinds of CRDTs and they work in different ways. The ones that I'm going to talk about, yes, that's what is happening. So there are these 2 open source projects. This one incidentally is by the same people who wrote that first paper that I think to. You can switch. So this is these are both CRDTs that basically represent JSON. So you can have objects and arrays and keys and values and stuff. And they've both got special support for merging changes on text, including rich text, because that turns out to be quite a hard part of this. And more or less, this is how it goes. You build a data structure that represents your to-do list. So you can imagine it's like an array of to-dos, and they've got a text and a completed flag. And in that data structure, in addition to the sort of the JSON value you initialize it with, it keeps a little log of the changes that have been made. And then what you do is you send that to all your different clients. So you've got different copies of it. And then one of these clients can go and say, check off a to-do. And in that little history, they checked off a to-do. Store a little transition. And then the other client can maybe add a question mark. And then the magic of CRDT is every CRDT has a merge operation that lets you take those 2 things, smush them together, and apply all the changes from both the versions to the data. So you end up with the equivalent of both users performing their tasks. Once you've done that, and you can have client 1 send it to client 2, or client 2 sends it to client 1, and you end up with both people have the same version of the state, and you can keep going. And the key thing with CRDTs is no matter what order you merge things in, you will always end up with a consistent result. So everybody's seeing the same thing. Because the worst thing would be is I say I've checked off all my tasks, you're saying I haven't, and then we start arguing over Zoom or something. So here's a little demo. I just nicked this from the auto merge documentation. I actually screen recorded my computer playing back the video because I couldn't get the videos embedded in Keynote. But there's 2 different tabs here, and you can see the changes are being replicated. So CRDTs are kind of awesome things. They are incredibly simple to work with. These 2 libraries are incredibly simple to work with, and they do this automatic synchronization for you. The downsides, so one is document size. We're storing a complete Git history for our data structure inside our document. And that's going to grow, and it's going to grow, and it's going to grow. And the data structure will gradually get larger and larger. So the good news is, so I know more about auto merge than I do about YJS, but auto merge has this binary encoding. It's actually all implemented in Rust. So it works on a web worker, and you talk to the web worker. You think you're just talking to a JSON object, but it's implemented in Rust, and you can export the thing as this compact binary representation. And if you think about the way we normally ship JSON objects across the network. You know, we've got all these big human readable keys that take up loads of bytes and all this kind of stuff. This thing's got all sorts of clever tricks to compact things down. So yes, document size can become a problem, but it's not as much of a problem as you think. And at some point you can always just go, right, well, I'm going to export the JSON, create a new document, put it back in and clear the history, that kind of thing. You just trim the history. Another big thing is this one, and the databases suffer from this a little bit as well. Just because you can always merge changes doesn't mean you end up with a document that's valid. So, you know, if one person deletes something from an array and another person modifies that thing, auto merge, for example, doesn't delete it, it makes the modification. That's its built-in rule for dealing with that. And you can't change those rules. And so you've got to be a little bit careful to make sure the application around the document doesn't produce sort of corrupt data. So where you normally see CRDTs used is for sort of representing things like the contents of a text editor, where it's quite hard to corrupt it. I can't explain the representations, but you know, if I type some text and you type some text and we end up with sort of gibberish, then whatever, right? One of us just rewrites it and we're fine. And in situations where you've got data that absolutely must be valid at all times and you have no tolerance for failure, then maybe this is not the right tool for you. And the other thing is that CRDTs only do part of the picture here. So they're doing the conflict resolution, but they're not sending things across the wire and so on.
Yeah, I was wondering,
right.
do the CRDTs inform you of issues merging? So that you can actually take it from.
So do the CRDTs inform you about issues when you merge? So a lot of changes can just be merged seamlessly, right? Where there are conflicts, the CRDTs will just make a choice. So if we have, I might have a video of some text editing later. If we have a sentence and I change a word to something and you change it to something else, it's just going to pick one. And so, and that's non-deterministic. It'll pick one sort of randomly, but it will always randomly pick the same choice each time. It's not going to, if we do the same merge again and again and again, it will always produce a consistent result, but you don't get any control over that. But you can sort of maybe mitigate that if you have some idiosyncrasies, you can build around it, I'm guessing. But these things only do the conflict resolution, except that, as I say, I know more about auto merge than YJS, and auto merge has some cool tooling with it. So it actually has a thing called a repository where you can save your CRDTs and it will serialize them. And then you can connect your repository to different data stores, and you can connect it to things like WebSockets, I can't really call it, browser messaging, where you can send messages between tabs locally, and all these different things. So it actually gives you an infrastructure to build an app that does do some syncing, especially if you only really want syncing to other clients. So this is a really, really promising tool. I really enjoyed it. I did a bit of tinkering with auto merge. It was really quite nice. So in conclusion, local first, hot take, spicy take. Local first is the future, right? I think this is the way things are going to go. And right now, I mean, it's hard to do. What I wanted to come away in this take home is to go, but the tools are kind of there now. I don't think they're quite there now. I think they're getting there. I think a couple of years ago, you would have to be Figma or Linear to do this, or Google Drive or whatever. But now there are enough tools that with smaller teams and with, you know, less time, you can kind of pick up on this stuff. And certainly for sort of quote unquote simple things, tools like auto merge really get you a long way very quickly. But I think in the next 2, 3, 5 years, this is going to be the way things are done. And we're all going to, I mean, we're not going to need to know much about the architecture because the tool will do it for us. But, you know, this is what we'll be doing. And I'm really excited about it. I think it's going to produce some really cool apps. Thank you very much. One last slide. It was not supposed to come up, slide, bullet by bullet. This website at the bottom, localfirstweb.dev, is a website. It's got masses of links to libraries, existing products, people to follow on your social media platform of choice, all this kind of stuff. Not produced by me, but I found it excellent as a sort of a quick, like a hub to get to all sorts of different information. Anyway, any questions?
Fantastic. Yeah, cheers, Dave. Now, out of interest, web.dev is not any relation to web.dev from Google, right? Okay, cool. Just
Everyone has to have a .dev domain name these days.
Yeah.
Got no plus library, you need .dev.
Just so you know, by the way, Dave was very conscientiously repeating questions so that those following along at home would be able to know as well. Right, I have loads of questions, but I'll be generous and see if anyone else wants to ask a question first. Peter, go for it.
Hi, Dave. Thanks for that. Does the data, as obviously it's on the local machines, but does it kind of live in the cloud, or does it live anywhere else?
So yeah, okay. So this is one of the things that I removed a slide. One of the things about this is local first is like it's a bit Web 2.0. It's like this buzzword that just encapsulates all this stuff. And the architectures you can use are just many and varied. And you've seen there's 3 different approaches to doing it there that are just completely different. So you could build an app. It really depends upon how the online part of your app works. So there are examples. Take Apple Notes. Apple Notes is quite a good example. You make a note on your iPhone, it just sits on your iPhone. If you don't have their backup service, that's where it sits. But if I can send you a text message, and then you can pick up a text message, and there's a link in there which loads that thing up. So there is some service where now when I make changes, it sends them to you, and you make changes and sends them to me. That's a CRDT. So the data doesn't need to live on a server anywhere as long as there is some way of sending it across. And one of the nice things about CRDTs is you can accumulate as many changes as you want, and they will always have a crack merging them all without causing, weird inconsistencies. Well, they won't create any inconsistencies, but without causing weird sentences to appear in the middle of your note, stuff like that. So the answer is, it depends, like anything. Yeah. Whereas take something like, actually, just to finish the thing, take something like Figma or something like Linear or something like Google Docs. They don't work without the server. I mean, we put them as local first on here because they're big products that everybody knows and they use similar sync technology. But they're not in the spirit of local first, which has all this other stuff like, well, if the company goes bust, I want to still be able to use my app, that kind of stuff. So there's different interpretations. The Ink and Switch paper is a really good read because it goes through all these different aspects of what this could mean and then how important they may or may not be to sort of take things moving forward.
Next question. Sorry.
So the apps you mentioned aren't local first. So what apps are?
Well, I would, so I would say your Apple Notes app. That's
Okay.
local first. The other note-taking app that I showed there, Goodnotes. That's a relatively recent thing. It's they've had great success. That's a note-taking app. Again, it's hand-drawn notes, but it just sits on your iPad. It's to do with an Apple Pencil, and then if you have multiple iPads, you want to share with your classmates because it's used in schools. There's ways of sharing. You hit share link. Again, you get a link you give to somebody else. So that kind of thing, you can imagine an architecture where you do the data just lives locally. I think my bias for web development is I probably want something where I can sign into an account and get a backup on the cloud fairly quickly because I don't trust myself to not clear the data in my browser. But I think on mobile, especially given that like Apple and Google both back up your apps and your data, then this kind of architecture makes it there's a lot less work to do to get it to be local first, properly local first.
Thanks.
That said, though, if you're a big company and you want to make money, and if you've got hold of people's data, then that's a great way to extract cash from it. So,
Instead of sort of thinking about the case of kind of I've been offline for half a day and I've done a load of stuff and now I want somebody else to get it or I want to send it centrally, thinking about the case of I've got 2 browser tabs open and as you were demonstrating, like nice and crisp, almost simultaneous stuff's happening. The information that's flowing between those 2 instances, is it literally every single change is just here was the parent and this is the operation?
Yeah, so again, depends on the architecture. For those do-it-yourself event sourcing things, you can pop open, well, the way Linear works is whenever you make a change, it actually sends a GraphQL mutation to the server. But then the updates from the server stream back over a WebSocket. So the thing you're sending up is literally, I changed this text field to that, or I assigned this task to Dave, and then that message is getting sent up, and the server is rejecting or accepting it. So, and one thing that is important to note there is this is another thing, another slide that I took out is because this is such a general concept, there are lots of different ways of categorizing your local first apps. So one is, how live is your sync? You know, do you want multiplayer, or are you Evernote, say, right? Like Evernote did this quite early on, and it would make sure all your notes are replicated across all your apps, but it's not, I'm editing my note, you can see it. It's saving a document and it's sending a stream of documents. And there are different challenges with both of those things. So on the live streaming multiplayer side, you've got a lot of data, it's going very quickly, you need to be really responsive. On the going offline for a week side of things, on the live streaming side, but if any of those messages gets rejected, then the consequences are probably small because you're looking at the screen and you just fix it. If you go offline for a week, it's the opposite. You've got a lot less data traffic, there's no scaling issues there. But if you can't merge that data at the end of the week, someone's going to be really annoyed. So yeah, different trade-offs. I think a lot of these approaches will work at both ends of the sort of spectrum, but you need to dig into how the thing you're using works. It's not always obvious from the documentation. So, yeah.
Someone pass it across to me.
Thanks. I'm trying to think how to ask this. There's like another kind of, I've heard like the term offline first, which is a slightly different thing. Did you look at like the actual like application itself, how would you manage that and like the updates and stuff? Because the issue is like, you push an update and then the client doesn't know about it and you've already loaded everything.
So, okay, do you mean like things like database migrations?
That might be an issue. Like if you end up with a client running an old version and you've changed everything.
Okay, so a few things there. So one is offline first, I think is basically very similar to local first. It's an older term, and the local first paper defines a new term to kind of say, well, this is like offline first, but we think network access is actually a really integral part of the problem. So it's like, it's not just offline. It does matter to be online. Offline makes it seem like you're not connected to anything, whereas local means, well, I'm doing things locally, but I can also be connected. So that's the terminology is all related, and it's all one sort of research field. In the case of changes to your local data and versioning, I mean, this is a problem. This is an interesting problem. So a lot of those database libraries will have tools for things like migrations, because you have to apply migrations to the server and the client, and you're not going to be able to do the lazy thing, which is to, like with a website, with my website that I build, we make a data migration, we just update the site and the server at the same time and hope that no one's still looking at the site. But you can't do that with a mobile app in general. Like, people don't upgrade off the same site, but also have a mobile app. And we have people who have not updated, even though I've pushed out a message to every user saying this old version of the app is about to be retired, not updated for 4 months, because they're not thinking about it. You know, it's just a tool. There's the Office iPad. Like, who cares? Just throw it in the corner at the end. So it's a huge problem. Yeah,
it can be even worse with web apps as well, because they can't update in the background really.
Right. Yeah, absolutely. That's another thing actually, is that with these very online local first apps, although we say there's no spinners, there's going to be a spinner when you do that first download.
How big are the bundles for the local data for these?
Well, like Linear, for example, downloads your entire database of all of your issues, with all the people in your team, with all the comments, with everything. Not 100%, but like 90% of it, enough to render the first few screens of the app all in one go.
Or does it not do it in the background?
I mean, I've not tried it with a big enough. I'm only a 2-person team, so we don't have enough issues. We make a lot of bugs actually, but we don't have enough issues.
The many tests.
so I can't tell, but yeah, I'm assuming, if you're Facebook or someone, you've got masses.
Thanks. Okay, well, I'm going to take a question. Thanks, David. I was really interested in this, and it did not disappoint. I wanted to ask about your assertion that we're all going to be doing this in 5 years' time, because in many respects I agree, and I think it's like a really good paradigm. But it kind of comes back to Roger's point as well again about how you deal with conflicts when they actually happen, because you've mentioned that auto merge will just pick a lane and just do whatever it thinks is best. That's kind of fine if you're editing a document together. It's not so fine if you're like defining payment rules or something like critical. So what happens in that scenario?
Well, so yes, obviously I was being slightly controversial. I think that is an important point. With stuff like payment systems, with stuff where data integrity is really important, I think you're likely to choose an architecture where there is a server in the middle, where you can control the server very directly. And then the event sourcing patterns, which are actually relatively common, especially in sort of back-end data warehousing kind of things. You just store every change so you can walk back and forth through your history. They give you more or less complete control, because you have to write all the merge rules yourself. You have to, the way replicache works, you create these things called mutations, and they're basically just, there's a JSON object that represents the change, and you write a JavaScript function that works a bit like a Redux reducer. Here's an action. Here's my current state of my database. What do I do? And so you hand code what happens. And then you do that once on the client and once on the server, 2 different JavaScript functions. They can be the same, but they can be different. And so because you're writing all the logic yourself, and in a sense, it's quite a simple architecture from the point of view of data integrity, because the server is dealing with one message at a time on a given data set, right? You might have 10 browsers all connected to the same server, but it is linearizing all of the updates they send into one big queue, and then going through everyone one by one, going, yep, note, back that out, yep, note, back that out. Where the challenge comes is when things come online later on and go, oh, wait a minute, I've been offline for 2 days. Here are my 2,000 changes, or clock drift and all this kind of stuff. But ultimately, the data integrity you can manage because you can write the code for it.
Yeah. Okay. Cool. That makes sense. You're convincing me more and more.
But you end up upsetting the user then, right? So like, oh, it just come back after 2 days. Sorry, all your changes are back.
Yeah, although that's where I think clever UX patterns will come into it, like of just like just indicating to a user, like, okay, we haven't been able to sort of verify this, like with all the other changes that have been going on and stuff. And it's interesting because, as some of you may know, I freaking love Read a Remix, which is like a hot JavaScript framework, and they're pretty bullish about optimistic updates. So you just click the thing, it just does the thing, and then in the background it's like fires off the network request, is like hopefully legit, and it's like it's very snappy and it's very nice. But then what if things go wrong? So I feel like there's a slight mismatch still in terms of UX, and like interestingly the UX needs to catch up with development patterns. But yeah,
just on that website you'll find a sequence of 3 talks by the CTO of Linear, a guy named Thomas Artman, and they're fascinating because he walks through the whole architecture. He kind of does this thing and makes it seem really simple. Then you kind of think, actually, it's not. But in there, he says, so they do all these optimistic update things. And he said in their whole app, there's about 15 cases where they have special error handling code. And the rest of it is just, you try to make the update. If not, it just backs it out. So they have this to me, very blasé approach of like, if I try to change the text field and you reject it, it just changes it back. It doesn't tell me, it just does it. But they get away with it, and they have really nice app design, and people love this product, right? So I guess you might get more mileage than you think. I don't know. I guess it depends on the domain, but yeah.
Yeah, it looks like Dave's got a point on that. Check my phone. Okay. Oh, okay. Thanks. Okay. Few questions. Sorry, bear with me. Sorry. It's
Oh, sorry. Yeah.
Yes, thank you very much.
Sorry, thank you. I mean, it's not so much a question as more like a thing in support of like this idea. I was sort of thinking about how we tend to assume that people have like fancy devices and an amazing internet connection and that they can just be connected forever and everything is fine. And that's not realistically the case all of the time. And I think having a paradigm that recognizes that and allows people who might not be in quite such a privileged position to use things is a good thing. Yeah. Like,
absolutely.
that was all I wanted to say.
Thank you. Okay.
It's a really good talk I could recommend on that, and I can't remember the speaker's name. But I'm going to have to. I'll talk to you in the pub after. You should be able to remember.
Apparently, Jake's lost your audio. Oh dear, it seems to be on. Can you hear me, Jake? Sorry, like we. Yeah. Okay, so you can hear me. So yeah, we'll see. I'll keep yabbering on in the meantime. I should have said in the thank yous at the start, by the way, that like Jake in particular for tonight has done a great job of like marshalling everything. Like I know I'm the one that stands up here, but we have a committee that helps organize everything, and frankly, everyone does everything else, and I'm just sort of stood up here and taking all the credit, which is not fair and not true. But yes, whilst that's happening, I might just sort of chuck this over to you, depending. Although, do you want to say a little tra-la-la-la to see if Jake can... Jake, hit me up. Anyway, I will read out this question in the meantime. Jan asks, Jan being the superstar behind async, how would you approach computationally expensive or scheduled tasks like search indexing or database hooks? Nice easy one for you.
Excellent. Do you want the server, mate? as someone who's definitely built these apps before, which I'm not, I'm guessing you would. That's the sort of thing where you would ship the work elsewhere or do it in the background in some way. So
that's fair enough. Although it does kind of boggle my mind that Postgres can just run on WASM in the browser now. But anyway, Jake can hear you again, so hooray. And something of an extension to that question, do you think GPU-intensive AI models would be feasible local first in the near future? Jesus, do all the easy ones for you.
Yes.
Yeah.
Sorry.
In case you couldn't hear him, there was a slight shrug there, I think. Roger.
Yeah, again, it's not so much a question, but like, I wonder if I should see it that way. Is this kind of like stealing from the blockchain model, where basically every object carries its own blockchain to every node?
One of the ways, I did see Merkle trees come up in a couple of architectures. It's one of the ways you can sort of work out I don't know enough about blockchain, but you sort of, every event, every action you take to change a bit of data, you get a hash of it. And then you put like a version on every record of data with a little hash. Because so one of the challenges you have to face when you have apps that can disappear offline for a while is they might come back online and then they've got a backlog of changes, and it looks like you need to know what version of the data they were starting with when they started to make those changes, which is not what you have anymore. And so if you care about this sort of thing enough, you have to unwind some changes you've got and rewind them on top. So there's all these algorithms. And to be clear, I actually think a bunch of the sort of the local first darlings are not doing any of this. Like they just don't care. Like it's not a problem for them. But like for anything where you do care about data integrity, you do need to think about this. So Merkle trees can help you calculate every object has a hash, and the hash is basically based on all of the actions that were applied to that in the past. So if the hash you have for an object here and the hash you have for an object there don't match up, you can start unwinding changes until you find a common ancestor. So yeah.
Thanks.
I'll pass back to you guys.
Oh, thanks. What was it? Do these systems take into account like when the changes were made? So, because also like
it depends. So every system will have some form of timestamping changes, and that's a whole world unto itself. So you can't just use timestamps because you get clock drift between systems. So there are at least 3 different ways of doing it. There's these things called vector clocks, there's a thing called Lamport timestamps, and there's a thing called hybrid logical clocks, which seem to be the thing. So a hybrid logical clock is a combination of a real timestamp, a little version number, and a client ID. I think Snowflake is a version of this. And it gives you a way that even if there's clock drift, you can work out a canonical ordering on things. Beyond that, you have to look up how it actually works, because I don't know the technical details, but there are ways of doing this, and yes, you do need to do it for some of these algorithms.
Yeah, I was kind of wondering in some situations if it actually makes sense to consider the time, but I think it might be
It's mostly about ordering.
more to do with the
It's
offline
like
thing.
if you have to zip 2 sequences of actions.
Yeah, but I was just thinking that like, or if you have like a sentence and then someone changes the word, what is it? Like you both write a sentence together, you have that version, your friend goes on holiday and has no internet for 2 weeks or something and decides to update that word, and then you update the word afterwards. Does that get replaced? But then they also didn't see your change. So it's kind of, that change was made on assumption of previous data, kind of.
This is my other auto merge demo. So this is their like starter app that you can install, and it runs on Vite. You have these, this is their rich text syncing functionality. So one of the things they talk about in their article that discusses this is that user intent is really important. So even if you have conflicting actions or actions that partially conflict, merging them as long as you can merge them together in a way where, you need to be able to merge them together in a way where you sort of preserve what the user is expecting would have happened. So this thing has got like this browser on the left here highlighted beautiful async in italic, and this thing highlighted async in bold. And there's 2 ways of merging that. One produces a bold italic word here, and one produces a bold word that is not italic. It depends on who sort of trumps who. And so they had this whole article about how they thought about what the user intent would be in a text editor. And there's all this stuff about how paragraph breaks and nested lists and things like this are represented. And it's not as trees as you might think. They use a different encoding. It's a really interesting topic.
Yeah.
You can go deep on.
I suppose probably they do. One thing they probably should just do though is kind of, particularly if, I suppose it's not an issue if you're writing it and you can see it getting kind of doing something unexpected, but I mean, even if you're just working in a different part of the document maybe, and that takes forever to sync, then it should probably just flag where it has no idea which way to do it.
You accidentally publish your press release with ChatGPT generated sentences in it. Who would do that? Exactly. It's never happened before.
I think this relates to the question that I had before, right? Like even if the system picks whatever rule and it always sticks to that rule, if it somehow logs what it did, then you can still use that log to at least, inform or do whatever you need to do.
Yeah, which Google Drive kind of does with the version history, I guess, right? So although it's not necessarily big gain to see what decisions their conflict resolution made. Yeah. Just one other quick point from me. You mentioned multiplayer like a few times, and semi-famously, React was somewhat based on that whole sort of re-render loop from games development, like from first-person shooters and stuff. It's like only render the thing that you need to see and all of that sort of jazz. Like, how much of this has actually been inspired by multiplayer games, and how much translates over from that sort of thing?
I think I don't know, because I don't know enough about game networking. Other than that, it's all pretty much just fire data at the other machine and hope it works. But the game engines have to do with all sorts of things like predicting where someone's going to be, like if a person is moving and a bullet is also flying. This is terrible. Someone's moving and a hug is flying at them at the same time. You've got to predict where they're going to be, even though they're turning or something. And I don't know if that stuff really factors in here. Maybe it does. I don't know. I'm waffling, so I don't really know. But it's an interesting question.
Call of Duty Hugs Edition is quite a nice idea there. Yeah, exactly same. Anyone? Yes, go for it.
Maybe taking your controversial statement too seriously, but do you see applicability beyond multiplayer text editing?
Yeah, so I mean, there are numerous examples of drawing apps, both raster drawing and vector drawing, and fairly reasonable numbers of examples of apps that are just like config screens synced up and things like this. I keep going back to linear because that's one of the ones that keeps coming up in this stuff, but like all of their setting screens work like this. It's a natural artifact of having the data locally on the machine. If something is just updating the data and then you have some reactive layer observing the data and changing what's in your user interface, then you can just have your UI live update. Whether that's a good idea or not is dependent on the app. But if the sync engine is doing the job of making sure your local data reflects everybody else's, then you get all of this stuff out of that. That's the important thing.
So the app doesn't necessarily need to be collaborative necessarily from a functional point of view.
Yeah.
It might just be a paradigm that just works.
You think about how we do. So if let's say you've got a little a form for editing some settings on the web, and the way you would normally program it is you'd download the JSON object you're editing, stick it in a use state if you're using React, and then at the end you would take the resulting data and you post it back to the website. You can easily, if you're using something like MobX, something like this, you can easily make it so that if something external to the user in your app changes that data, then the form updates. That's either a good thing or a bad thing, depending upon what you're trying to do. Do you want the user interface, the data in front of you to constantly be updating as the user's typing? Well, maybe not, in which case you take a copy and you disconnect it from whatever observer you got. So it's kind of the same principle. It's just a different mechanism that's giving the data. If you were doing that remotely, though, and you wanted to stream changes, you'd have to be polling the server all the time. That's the only other thing. I mean,
Okay, thank you.
Great.
So I have a question about another buzzword, end-to-end encryption. How does this intersect with local first development?
That I don't know, but I know that on that website I linked at the end, there are a couple of people who are really into that. And things like how do you do authentication and permissions when you have no central server? That's another one. So having capabilities and certificates that, I'm talking way out of my depth here, but there's prior art out there. Yeah.
Okay.
I'll find the speaker and the talk that I'm thinking of, and I'll share it with you afterwards.
Great, thank you.
James Hugman, everyone, making speakers sigh when he asks a question since 2010. Anyone who hasn't asked a question want to ask a question? I feel like we should probably let Dave off now. He's been fired with questions for the last 40 minutes or so. So yeah, please give a big round of applause to Dave. I know you can't see me, Jay, but hopefully you can hear me. So that's a wrap, folks. We are going to head to Unbarred, which is turn right out of here, turn right, and then you'll see it at the bottom of the hill on the left. There will be hopefully a steady trickle of asyncers heading down that way. We are going to next meet in October, the first Thursday of October. Whatever date that is as an exercise to the listener, I've forgotten, sorry. And the speaker will be none other than James Hugman, and he is going to be talking about React and Rust bindings for React and some other special sauce sprinkled on top from it, which I will have to remind myself on. But yeah, it will be a fantastic one. Please come along to that. And yeah, I think that's it. Is there anything else I've forgotten? Is anyone? What do I normally say at this point? Just yeah, thanks for coming. It's wonderful to see you all. Huge round of applause.